In this video, we're going to be discussing how to sketch graphs of exponential functions very easily. Okay, so we're going to go ahead and start with this. A few basic premises. Starting with this one, we say an exponential function is y equals a to the power of x. Okay, so what I'd like to do is kind of expand this. You know, I like to use f of x or function notation, but it'd be the same thing as if I said like a to the power of x minus h plus k. Where we have an a, an h, and a k value. But this is really important to me because if we can memorize the basic graph of y equals a to the x, then really what I can tell you is this. In terms of graphing y equals a to the power of x minus h plus k, what I want us to recognize is h is just horizontal translation. So horizontal shift, and it's lying. So we say liar. It's actually because of the negative in the formula up here, because of this minus sign. What it says is not what it means. It means the opposite, okay? And we say k, this is a vertical translation or vertical shift, okay? We say it is honest. It is honest with us. So I'm going to go ahead and start with just like a really straightforward thing. If I said, oh, go graph y equals 3 to the power of x. A few things I would want to notice about this right off the bat are these. We say, well, it's an exponential function, of course. What I know about the basic graph of exponential functions is that they have an asymptote that is the x-axis. It'd be this guy right here, y equals 0. I know that it goes to the point 0, 1. This would be very easy to check, by the way, 0, 1. Here's how we might do it. We'd say, all right, we'll plug in 0 for x. See what you get for y. We get 3 to the 0. We get 1. And then the other thing is this. Because the base is this a value here is 1. Or 3, sorry, 3. When I plug in 1, I would be at a point of 3. So plug in 1, I would be at a height of 3. So this would be essentially our y equals 3 to the x kind of like power function rockin', okay? So instead of graphing this, possibly or perhaps I would want to graph something like this, y equals 3 to the power of x plus 2. Okay, so what I want to notice here are these things. First of all, a is the same thing. A is the same thing. Our h value here, we say h is actually negative 2. It's going to be shifted left 2. So left 2. And then we have no k value out here, so it's not going to shift up and down at all. So here's how I would sketch this, honestly. You know, maybe I'll pull out a bluey would be good, a bluish. I graphed the original function that has an asymptote on the x-axis. So it goes to the point 0, 1 and the point 1, 3 in this instance. But I would just take all the points that I had and I'd shift them left 2. So instead of going to the point 0, 1, this point would now be at negative 2, 1. And instead of going through 1, 3, shift this left twice, it's going to be over here at negative 1, 3. So the same graph shifted left twice would just essentially look like this. Nothing too big. Let's go maybe a new set of axes. We say y equals now 3 to the x. What if I were to put plus 2 on the outside? Okay, so you'll notice here no h value. Okay, but we have a k value, and our a value here is 3. So sketching it, we'd say, okay, well, I know that my original function has an asymptote on the that wasn't very dotted or dashed. There we go. The original asymptote would be here. It would go through the point 0, 1. In this case, if there was no plus 2, it would go through the point 1, 3. So we're graphing just the basic parent y equals 3 to the x function, and then we're just going to translate this. Okay, so we'd say in this instance, since since k is plus 2, we'll just shift this up twice. So we'll take everything we have, we'll shift it up twice. So instead of the point, why don't we switch back to a green again? That'd be nice. Instead of the point 0, 1, it'll be at the point 0, 3. And instead of the point 1, 3, it'll be 1, 5. The important thing to notice here is this. Our k value out here, we typically have an asymptote at y equals 0. But in this instance, if everything shifts up twice, seriously everything, then the asymptote must also shift up twice. So a couple things we're going to say about this one. First of all, the asymptote is at y equals 2. And this would be our new graph. It's been shifted up twice. But the second thing is this. If the parent function always has an asymptote at y equals 0, and the new graph has an asymptote at y equals 2, which was our k value, well, k always shifts exponential graphs up or down, k units. So I think that we should be able to go so far as to say the horizontal asymptote. Horizontal asymptote always at y equals whatever k is, because if I'm shifting it from the ground level up or down, whatever k units, then that's what I have to deal with. Okay, a couple more real quick. We say, how about this? Y equals 3 to the power of x minus 1 plus, how about 3? Okay, so to graph this, I'm just telling you, why don't you just go graph this one first? Go graph this first. We know what this one looks like. We know it has an asymptote automatically. All exponential functions have an asymptote on the x-axis. They go through the point 0, 1. In this instance, our a value is 3, so it'll go through 1, 3, and look like this. This graph, however, has been shifted, okay? So in this instance, we'd say it's been shifted actually right 1, so right 1 unit and up 3 units. So if we go right 1 up 3 here, then we'd say, well, this would go right 1 up 3. It'll now be at this point. This one going right 1 up 3 would now be at this point. And then also, since it shifted up 3, the new height of the new asymptote should be at y equals 3. So this will be y equals 3, or y equals k value. Really, that's our k value. And look like this. So really, just a lot of the graph theory we've seen in the past. Okay, so one last note I want to mention on this is reflections. Okay, so we say reflection. If I were to say go graph y equals 3 to the negative x now, okay, since we plugged in a negative x, it would be the same as our original graph. Went through 0, 1, in this case 1, 3, has an asymptote at the x-axis, looks like this. Since we plug, kind of sloppy. Since we plugged in a negative x, really it's just reflect about y. So we say reflect about the y-axis. This always happens with graphs. So it'll still go through 0, 1. Instead of going through 1, 3, it'll go through negative 1, 3, and instead it should look like this and just be reflected about that. Whereas if I were to graph now this, y equals negative 3 to the x, that is negative 3 to the x, this is like plugging in a negative y. Okay, I can prove this. If I were to write negative y equals 3 to the positive x, see I plugged in a negative y. But if I have a negative out front, essentially it's this. We could say, all right, well, it's my original parent function. Goes through 0, 1. In this case, go through 1, 3. If I hadn't done anything to it, it would look like this. But since I plugged in a negative y, it'll be reflected about my x. So instead of going through 0, 1, it'll go through 0, negative 1. Instead of going through 1, 3, it'll go through 1, negative 3. Okay. So essentially, all of these graphs. Why don't we start just one more quick canvas here, and I'll pick a black color, and we'll fill in a few things. Why don't you write this down if you're taking notes? We say all graphs exponential look somewhat like this, where we'd say, okay, so we say horizontal asymptote at y equals k. Okay, so we'd say h is horizontal shift, k is vertical shift. And we said, remember, k is honest, and h is not honest, it's dishonest. Okay, cheers.